Action. Okay. What I'd like us to do is consider the following. I'll write down an example. And say you had to find the equation of the tangent to the curve y equals 2x cubed take away 3x at the point where x equals 1. Before we even attempt this question, let's just see what that looks like. So you've got 2x cubed, so f of x equals 2x cubed, take away 3x, and there we have it. Okay? So let's just be clear about what's going on. Now, I'll zoom in, and what I'm going to do is take a point and put it on this object. So I'll do that. And I'll also work out the tangent at that point to the curve. So now look what I could do. I can move this point around, and as you can see, the gradient of the tangent next to the x is now changing. Okay, so here it becomes 0, here it's negative, and here it's positive. And what they're saying is when x equals 1, at that point, work out the actual gradient. Now I could do one step further actually. One thing I can do is to give you the slope at that point. There you go. Right? So you can tell the gradient is actually 3 at that particular point. And this line here, let's just be clear, this line here, I'll use a different colour. Let's make that red. This is the tangent. So the tangent to the curve at that point is what you see there. Okay? Is that clear? Why don't we take a picture of that so it's part of our notes. And let's put a picture in. Okay, so that's what we've got. And we need to work out the equation of this tangent. So what we're going to do is we know the gradient. So we know the gradient m equals dy of dx. And this 3 times 2 is 6x squared take away 3. So that's the gradient of y at any point. I'm going to tell the examiner at x equals 1, the gradient equals 6 times 1. I'm going to substitute the numbers in and not do things in my head. So that gives me 6 take away 3, which is 3, which is obviously correct. I can see that from the picture here. Now I'm going to again tell the examiner what I'm doing. So I'm going to write the formula down. Y minus y1 equals mx minus x1. We know what x is. They've given it here. We know what m is. They've given it here. How do you work out what y1 is? How do you work out y? Substitute it in. So y equals, when x equals 1, 2 times 1 take away 3, which is minus 1. So my coordinate now is 1 minus 1. Now I can substitute in. And again, don't try and do things in your head. A, if you do make a mistake, you'll end up losing the method marks and possibly the accuracy marks, depending on the question. But B, if you write things out, you're less likely to make mistakes. So y minus y1, I'll write 2 minuses there, equals mx minus x1, which is 1. So y plus 1 equals 3x take away 3. And therefore y equals 3x take away 4. And this is now the equation of the tangent. Is that clear? Right. Let's extend this idea and say find the equation of the normal at x equals 1. Again, what we're talking about, what we mean is that there has to be a perpendicular line at this point. I can just bring this up here. Let's have a look. We want just a perpendicular line, so I'll click the line, I'll click the point, and now I get a perpendicular line. let's color code, let's make that B. Okay. At that point, the perpendicular line is 90 degrees to the tangent. Okay. And so if we, let's take a picture of that again. Okay, let's put this in. Okay. And we should ideally just label this stuff. So let's just put a few labels in and just write down, this is the normal, and this here is our tangent, and this here is our y. Okay. Now we know the coordinate is 1 minus 1. We know y equals x cubed, 2x cubed, take away 3x. We know the gradient dy over dx equals 6x squared, take away 3. When x equals 1, m equals 3. This is for the tangent. Therefore, the normal, if I can call this the gradient for the normal, is minus 1 over the gradient for the tangent. So it must be minus a third. Again, we use y minus y1 equals mx minus x1. Substitute your values of x and y in. So we've got x is 1, so y is minus 1, is that right? We've got minus the third, x minus 1. And we've got minus the third x. Now, over here, one of the things you can do, in fact, is to avoid playing around with fractions, you can simply multiply both sides by 3. So we'll end up with 3y, that's plus 1, so it must be plus 3, equals minus x plus 1. And so 3y equals minus x, 1 take away 3 is minus 2. And then in some questions, they actually want it in the form ax plus by plus c equals 0, or something like that. Or you can just simply write down minus x over 3 minus 2 over 3. I guess you could put it in that form if you want to, but it is in one of those forms. Okay, and that's it. That's your equation of the normal, which is perpendicular to the tangent. Is that clear?
How do you get m?
M is always equal to dy over dx. So for the tangent, m is dy over dx. For the normal, it's minus 1 over the tangent. Yeah? Because we know the gradient of normal times the gradient of tangent is minus 1. So minus 1 divided by the gradient of the tangent would give us the gradient. In fact, let me write like this. So the gradient of the normal is as such. Is that okay? So, as an example, as an exercise, something you could do is for y equals 2x cubed, take away 3x, find the equation of the tangent when x equals minus 1. Okay, I'll give you a couple of minutes to have a go at that. Off you go. Alright, so from here we can see what we should have got for the tangent, which is the red line, is y equals 3x plus 4 when x equals minus 1. And we can also work out the equation of the normal as so. Okay, what I'd like you to do is have a go at this question here now and see what you make of it. I'll give you a couple of minutes and I'll put up the answers just so you can check whether you're on the right lines. Off you go. Right, so with this example here, I'm just going to do the second part. The first part, you should have got x equals 5 over 3 or x equals minus 1. That essentially comes from working out dy over dx is 3x squared minus 2x plus 1, and we set that equal to 6. We then get a quadratic, so you've got 3x squared, take away 2x, take away 5 equals 0. And then if you factorize it, we should get 3x minus 5 and x plus 1, and then that gives us our answers there. Now, to work out the x-coordinate of the curve, for which the gradient of the normal is minus a half, what we'll have to do is, if the gradient of the normal is minus half, it follows the gradient of the tangent must be 2. And therefore dy over dx equals 2, and that means 3x squared take away 2x plus 1 equals 2. If we then go ahead and solve that, firstly it should give us a new quadratic, so 3x squared take away 2x plus 1 take away 2 is minus 1. We can then factorize it, so you've got 3x plus 1 x minus 1, and then this gives us x equals minus 3 or x equals 1.